As I have said in the notes, ethers are not that reactive. However, we do have one reaction that allows us to convert our ethers into alkyl halides. This reaction is called the acidic cleavage of ethers. To do this reaction, you will need your ether, excess amounts of a HX, in this case I'm using HI, heat, and you will generate two different alkyl halides if you have a asymmetrical ether, and you will generate water. To begin with, I'm going to do a symmetrical ether, and we will go through the mechanism using this. Okay, so we have our ether, and we have HI. The ether will protonate, and we will kick off the I minus. Now we have a positive charge on our ether, on the oxygen. And we have the I minus. Okay, so what we have, essentially looking at right here, is we have a good leaving group and we have a good nucleophile. And so the I minus is going to perform backside attack, and it's going to kick off this good leaving group. And when it does that, you're going to end up having CH3I formed, and now you have this alcohol. Okay, and so what we're able to do, since it's excess HI, we can't just stop it there. We have to go all the way to the end. And so to get to the end, we'll always use excess amounts of our HX reagent. And so we're going to do this same step one more time. Okay, so we deprotonate the HI, protonating the oxygen on this now alcohol, and we will form a positive charge on this oxygen, and we have the I minus. Again, similar situation as before. We have a good nucleophile, we have something that is a good leaving group, and so we're going to see this backside attack, and we're going to see water leave in this last step. We have now formed water, and again, CH3I. Okay, it doesn't matter how long your ether chains are, it will perform this reaction no matter what. Okay, there is one example that I want you to pay attention to, and I want to point out. Okay, in this case, we have a aromatic ring attached to our ether. Okay, so we have a phenyl group. And so what we're going to do is what you will see is we don't form two different alkyl halides. We only form one alkyl halide, and that is the alkyl halide that is not part of the phenyl group. And you are going to maintain the phenyl group attached to the oxygen, and that gives you phenol. There will be no water generated in this process, and again, we are still doing excess HI. The reason that we do not go all the way and create a two alkyl groups and one alkyl group on the aromatic ring is because this carbon is sp2. And so I wanted to point this out because I want you guys to remember that sp2 carbons cannot undergo SN2 reactions. We cannot perform a backside attack of these carbons. Okay, backside attack can only occur at an sp3 carbon or tetrahedral carbon. So keep that in mind when you guys are doing these types of reactions.